Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 6 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 3578. Count partitions with the max-min difference at most k, right? So in this problem you are given an integer array nums and an integer k, right? Your task is to partition nums into one or more non-empty contiguous segments such that in each segment the difference between its maximum and minimum elements is at most k, right? It should not be more than k, right? We have to return the total number of ways to partition nums under this condition, right? And since the answer may be too large, we have to return it modulo 10 raised to power 9 plus 7. Okay, so here see this example number 1, right? So this is my nums array and k value, right? So in how many different ways we can partition, right? So we can partition it like this, we can partition it like this, we can partition it like this, like this, like this, like this. So there are 6 valid partitions where the difference between the maximum and minimum elements in each segment is at most k, right? So here we can take individual elements, right? So here minimum element is 9, max element is also 9, so 9 minus 9 is 0, and 0 is smaller than 4. We are good, right? Here also if you see 3 7 7 minus 3 4, 4 is equal to 4, good. So difference should not be greater than this k, right? So in all these if you see difference is not greater than k, right? In all these, right, difference is not greater than k of the maximum and minimum element, right? So 6 valid partitions are possible, output is 6, right? Here there are 2 valid partitions that satisfies the given condition, that is this 3 3 4, right? Individual elements we can take because in the individual elements maximum and minimum is the same element, right? So it is also valid, this is also valid, right? Max and minimum both are 3, 3 minus 3 0, 0 is equal to 0, right? That's it. And here if you see the constants, so nums dot length from 2 to 5 into 10 to the power 4, and nums of I values from 1 to 10 to the power 9, and k values from 0 to 10 raised to the power 9. Okay, so now how we are going to solve this, right? So let's do one thing, let's take this same example, example number 1, right? So here let's suppose you have just one element, right? Just one element. So tell me how many different partitions you can form until now, valid partitions, right? The which are ending at this 9, right? So only one, right? Only one is possible, right? That's it, only one is possible. And how many empty you can form? Empty also you can form only one, right? If there are no elements, right? If there is only one element ending at 9, so only one you can form, right? Same way, how many valid partitions you can form ending at this 4, right? So valid one, right? So you can form this is 1, right? This is 1, right? So only one you can form, right? So one is just 9 and one is just 4, right? So only one is possible, right? So here min and max element is 9, here also min and max element is 9, right? 4, right? So here also difference is 0, 0 is less than k, less than equal to k. Here also 0 is less than equal to k. So only one way is possible, right? Only one way is possible, right? 9 and 4, right? So here see 9 and 4 we can take individually everywhere, right? Until 4 ending at 4, not ending at 1, right? So this is what I'm saying. Okay, it will get more clear when I'm moving further, right? So here ending at 1, ending at 1. So ending at 1, see this is valid 9 4 and 1, this is valid 1, right? 9 4 1. Same way this is also valid, right? 9 and 4 1, right? This is also valid. So here two ways, right? One is this way, individual elements if you pick until 1, and one is this one valid, right? So because here max element is 4, min element is 1, so this is less than equal to k, right? It's true. So this is also valid. So two ways, right? There are only two ways. Okay, now let's proceed further. Let's take this 3 now, right? Ending at 3. Now I need ending at 3. So one is this individual 9 4 1 and this 3, right? This is 1, this is 1, right? This is 1. Okay, now after that you can take this as well, right? 9 4 1 and then take 3. This is also valid, right? This is also valid. Anything else? You can take this as well. 9 4 1 and 3. This is also valid, right? This is also valid. Clear? Anything else? You can take this now. 9. Let me use this green color. You can take this as well. 9 4 1 and 3, right? Combination of this. So this is also valid, right? This is also valid. So total 4 ways if you see here, right? Total 4 ending at 3, right? These are you can take, right? These many. So here also 4 minus 3 or 4 minus 1 is 3. 3 is less than equal to k, right? Valid. All these are valid, right? So 4 ways. Okay, now ending at 7. Ending at 7. So ending at 7, here you have 6 ways, right? These are the 6 ways ending at 7. Okay, this is clear. These are the 6 ways, right? Here ending at 7. So what I did step by step. If I have only until 9, if I have only until 4, if I have only until 1, if I have only until 3, and if I have only until 7. So until 7 6 ways, until this 3 4 ways, until this 1 2 ways, until this 4 1 way, until this 9 1 way, and if we don't take any element there is also 1 way, right? Empty subarray, only 1 way, right? Okay, this is clear. Now here let's do one thing. Let's say this is nothing but my dp of 0, right? This is nothing but my dp of 1. This is nothing but my dp of 2. Okay, this is nothing but my dp of 3, right? And this is nothing but my dp of 4, and this is nothing but my dp of 5, right? dp of 5, just to refer this as dp of 5. Okay, 6 ways. All right. Okay, so dp of 5 value is 6, right? So here if I just write my dp array, right? Okay, 1 second. If I just write this dp array, okay, something like this. Okay, so at 0 1 way. If only one element I have, then also 1 way. If I have 2 elements for the above example, then also there is only 1 way to get, right? If I take 3, right? So in that case 2 ways. If I take 4, then I have 4 ways, and if I take 5 I have 6 ways, right? So this is how I filled this value. Okay, I filled this, right? Okay, this is clear, right? This part is clear, right? How I'm filling this dp. Okay, now here dp is nothing but dp of I. Dp of I, it is nothing but the number of ways, number of valid ways, you can say number of valid ways to partition nums from 0 to I minus 1, right? So here I minus 1. So dp of 1 means until 0 to 0, right? So only one element. dp of 2 means 0 to 1, that is nothing but 2 elements, right? 0 and 1. So here only one element I'm taking 0. Here I'm taking 0 to 1. Here I'm taking 0 to 2, right? This is nothing but 0 to 3. And here in dp of 5 I'm taking all the elements, right? 0 to 4 index, right? This indexing I'm saying 0 1 2 3 4. Okay, so this is nothing but your dp. Okay, right? Now here, see, uh, let's say you have 9, 4, 1 and 3. Okay, until here what is the value? Until here what is the value? dp of 4, right? So 4, right? 4 is the valid output, right? 4 valid ways, right? Now if you have 7, right? Here you have 7 comes, right? So tell me, this 7, right? This 7 can form a combination with this 3 and 7, right? Right? I can take 7 individually, but I can also take 7 along with the 3, but I can't take this 7 with 137, right? Here 94 and here 137, like this, 941 and then 37, and here 9413 and then 7. So here among them, this is going to give me the valid output, right? This is going to give me the valid output, right? Because this is valid, but this is also valid, right? 3 and 7. Here 7 is the max, min is 3, and this value is less than equal to k, right? 4 is less than equal to 4. So this is valid, but this is not valid, because here 7 mean minus 1 is less than equal to k. No. 6 is less than equal to 4. No. So this is not valid, but this is valid. Okay. Okay. So now I know this, right? This is valid. So I can do one thing now. Here I can do one thing, right? So okay, so until here what is the output I have? Until here 941. So until here what is the output I have? 941. I have 2, right? I have 2 here until here. Okay, and here until this 3. Okay, until this, until here what is the output I have, right? Until here what is the output? Okay, so until here the output is nothing but at dp of this is nothing but 4, right? At dp of 4 I have this answer, right? So 4, so 2 and plus 4 is equal to 6, right? 6 is for 7. So for 7 actually, if you see, for 7, right, when I add 7, so this is valid. Let's say this part is valid, right? Max. So L to R, this is valid. Okay, so this okay, so here that simply means dp of this L, right? This L. Okay, so here if I just give the indexing, right, this is valid, right? So here if I just write it in form of this indexing, so dp of 3, and here R is nothing but dp of 4, right? dp of 3 is nothing but 2, and dp of 4 is nothing but 4, right? That is nothing but 6. 6 is the output actually. Don't worry how I'm getting it, okay, as of now. So here if you notice, this is valid, right? This part is valid. Okay, 3 and 7, right? So in I can use this segment, right? I can use this segment. If I'm with the equation of 7, I can use this segment. So if I'm using this segment, then as whole what is this value, and until here what is the value I have, right? This is what I'm taking. Okay, this is what I'm taking, right? If we take some more example, then it will be more clear actually. But here just keep it in mind that I'm doing dp of 3 plus dp of 4, right? And I'm getting 6. Okay, so if right now I'm able to do this, right? Like for this 2 and 4, if I'm doing addition, I'm getting this 6. Okay, here let's take some other example also. Let's take some other examples. Okay, so let's say you have 9, 4, 1, and then you plan to add 3 here. Okay, let's say something like this, right? Now here if you notice, this is the one big that I can take, right? 9413, this is valid, right? With the inclusion of 3, I can take this as one valid segment, right? With the inclusion of 3, right? So here 0 1 2 3, right? So what you need to do in this case, you have to add what? You have to add now uh, dp of 1, right? This is valid, this part is valid, right? This part is valid. So dp of 1 plus dp of 2 plus dp of 3, this is what you need to do, right? This is the valid, right? So dp of 1 means, dp of 1 is nothing but 1 here, right? Just put these values. dp of 1 is 1 and 2 and 3, right? So 1 plus 1 plus 2, 4. So it is saying 4. So see, we are getting 4 here, right? We are getting 4 here, right? See, we are getting 4 here directly, right? So 1 2 and 3, this is one valid big segment. So I need this dp of 1 plus dp of 2 plus dp of 3, then only I am getting 4, right? The output is clear, right? 4 elements I'm taking, dp of 4 is nothing but these 4, okay? So I'm getting 4, right? So because dp of 1 is already storing the answer until here, right? dp of 2 is already storing until here, dp of 3 is already storing until here. So this result I'm getting, right? Okay, but here can I do, like for this 4, for this 6 I am doing this and this addition and getting 6, for this 4 I am doing these 3 addition and then I am doing this, okay? And here it is clear, right, how I'm doing. But do I want to calculate all these values of n time, right? This can be very big. Here I'm taking this of n. So what I can do here, in this dp also I can store the prefix sums. I can store the prefix sum in this dp array, right? So that I can get the result in of 1. So this is my approach. This is going to be my approach, okay? So here instead of 1 plus 1 plus 2, write 4. So I will find one shortcut. So what is going to be my shortcut? So for this 4, how can I do it until here? What is the sum? 2 plus 1 plus 3 plus 4, right? Clear? And I need until here. So until here I will subtract like this. So 2 3 4 5, total is 5 actually, sorry. Until here it is 5, and until here it is 1. 5 minus 1, I will get 4. So 4 is nothing but sum of this. So this is how I will do, right? So I have dp like this, dp like this, okay? 1 1, right? I'm just filling the values. 1 1 1 2 4 and 6, 0 1 2 3 4 5. So now let me show you how you are going to fill the pre, right? So you have to create a same array like this, right? This is your pre, right? So now what is your array? Your array is nothing but 94137, right? 94137, 9 9 4 1 3 and 7. This is what you have, right? So here pre is very easy to calculate, okay? What you need to do here, here just initially just put 1 here, right? And pre of this value, right? Pre of this value you can compute it as uh, this value plus this value, right? Just like this you have to compute. 1 plus 1 2, 2 plus 1 3, 3 plus 2 is 5, 5 plus 4 is 9, 9 plus 6 is 15. So this is how you can compute, right? This is how you can compute. Now it is very easy, right? So here if I ask you to give me this value, right? So what you can do, you have to take this you have to take this complete, right? If I ask you this, you have to take this complete, and from here you have to subtract this. You already know that these 3 elements we have to take, right, from here. So 5 minus 1 directly you can do instead of going this, okay? Same way, same way, if I ask you this, right? If I ask you this, you can easily do one thing. You can take this complete, and you know that only 2 elements are forming this, right? 3 7, right? So you can do one thing here. 2 means just subtract, take 2 and here subtract. So with 9 minus 3 6, Okay, 6 is the value you are going to get here, right? 9 and until here 3. So in between you are going to get 9 minus 3. Okay, here what is the value, here what is the value until here, right? So this is how actually you need to do it, right? So we will see what is the code that I'm going to use to fill this prefix. Okay, don't worry about this, but this is a shortcut that I'm going to take. Okay, and now next thing, how I'm going to make sure that I am taking valid segments every time, right? Until here what is the valid segment, 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 until here what is the valid segment. This I need to see, right? So for this one, what you can do here, okay, so let's take the same array 94137. Okay, 94137, right? So what you can do here, so you have to create actually two arrays, okay, deques you can say. So what you have to do, you have to create one max d, right? So max d is going to do one thing, it is going to maintains the maximum of the current window, you can say current window, right? So it is a, you can say, monotonic decreasing deque, right? All the values will be in decreasing, monotonic decreasing deque, and front element is always going to be the largest one. Okay, this is what I'm going to do. I'm going to create one deque, array deque, and one deque I'm going to create of main d. So it is going to maintain the same thing, maintains the minimum of the current window, right? I will show you in code how I'm going to do this. Okay, minimum of the current window, and it is a monotonic decreasing, so it is a monotonic increasing, you can say monotonic increasing deque, and here front is going to be the smallest one. Okay, just keep this in mind. Okay, so what I'm going to do here, until here, see, max and min is going to be same elements, right? So that's it, and the both are valid, right? Then next time 4 is going to come. Okay, so max is going to maintain the maximum of the current window, and it is a monotonic decreasing deque, right? So my max is going to become like this 94, and here it is going to become min. So min is going to become, it maintains the minimum of the current window, and monotonic increasing, and front is going to smallest. So front is going to smallest, so definitely I can't take 9 and 4, I have to take only 4, right? So now this is invalid, right? This is invalid because here the difference is greater than equal to k, right? Greater than k, right? So it should be 9 minus 4, it should be less than equal to k, right? If this is a k, then it is valid, but it's not valid, right? K is 4, right? So what you are going to do, your r is here, right? So whatever the value in the left, you have to remove it. So you have to remove this. Okay, now your left is going to move here, right? So see here again, I'm taking only this as a valid one, right? Next time you move to 1. So if you move to 1, so your front is this one, max is going to become 4 1, right? Because it is nothing but it maintains the maximum of the current window and monotonic decreasing, right? And here next one is going to become 1, right? Because I have to remove this 4, right? Because here it maintains the minimum of the current element, right? Maintains the minimum of the current index, and it is a monotonic increasing deque, right? Maintains the minimum of the current window, right? So this is what we need to do. Okay, but this is a valid window. So if this is one valid window, so that simply means that this is good, right? This is making one combination, right? Same way next time, okay, there's no need of deletion. Next time what 3 is going to come. So if 3 is going to come, 4 1 and 3, but this is not valid, right? Because max is maintain the maximum of the current window, and it is a monotonic decreasing deque, so we have to remove this 1 and we have to add this 3. Okay, same way here mainly it maintains the minimum of the current window, and it is a monotonic increasing deque, right? So here we can add 3, but this is also one valid, right? this is also one valid. Okay, R is here, L is here, so L and R still valid window, right? So and we easily calculate the prefix, right? We are calculate the prefix above, right? We know the range. Okay, next time 7, so 7 is going to come, so 3 is going to remove, and 4 and 7 I'm going to keep, and here 1 3 and 7 I'm going to keep. Okay, so this is how, but this is not valid, right? 4 and 1 3 7, this is not valid, right? So what going to do, I'm going to shrink this, so L is going to reach here, so there is this deletion, right? But here this is still valid, right? But still difference is greater than this, so L I'm going to shrink here, so only 2 elements. Okay, like this I have to maintain. Okay, I will show you code, but let me show you the debug statement. Actually very easy. All right, so this is your code, right? Example number 1, right? So this is your array. Okay, so what you have to do, okay, R is equal to 0, only one element is there, max d this, final window this, max and min is this one only, and total is 1. Okay, we are not removing anything, so dp of 1 1 and pre of 1 is I'm keeping 2, right? We are feeding the correct things only, right? So dp of 1 is pre1 is equal to 2, right? Then nums of 1 is equal to 4, then we have to remove this 9, right? Because max is going to become this, but window is invalid, so we have to shrink the left is going to become, the left is 0, right? That's what we need to shrink. The nums of left is going to be 9, so I'm removing this 9, so max is this. Okay, this is one valid window. So in this, if you see, total is nothing but as of now 2, but remove is 1, so we are going to get dp of 2 is equal to 1 and pre is equal to this 3, right? Good. Now after this r is equal to 2, so this value, so 4. Okay, so min d dot poll last removing 4, so max d is going to become like this. I told you that we have to keep the uh, elements like this only, right? Here in the decreasing, right? And here min d here, that's what I removed, right? From min d I remove 1, so valid window is this. Okay, so then again max min total you are going to calculate remove, so dp of 3 you are going to get 2 and it is going to get 5. Okay, same way here r is equal to 3, so you are going to get something like this 4313, and here this is valid, so again dp of 4 4 and pre 4 is equal to this 9 you are going to get. Okay, same way in the end, so max d first you are removing 3 4. Okay, you are going to get something this, but this is invalid, right? So left is 1, you are going to remove this, but still if you see, if you remove 4, right? So initially 4 was here, right? 4 7, so you will remove it, so now you're going to get this, but this is still invalid. So again from here you you need to remove this. Now this is valid, right? So this is valid, so now final value window is this. So max 7 and min 3, so total you are going to get 9, remove is 3, so 9 minus 3 you are going to get 6, pre is 15, that's it. Okay, so this is what we have to do. Okay, so let's write the code, right? Nothing complex, whatever I explained I will do the same thing. Okay, so what you need to do here, first thing, so let's create one variable int n. Int n is equal to nums dot length. Okay, and then here final int mode value is equal to 1 underscore 1 2 3 4 5 6 7 8 9, done. And then you have to create one this dp, okay, and give the size as new int, and here n plus 1, and you have to create one pre and give the same size. Okay, new int n plus 1, right? And after that, base case you can say dp of 0 is equal to 1, right? So there is exactly one way to partition an empty prefix, that is choosing nothing, right? So that's what I'm doing here, and pre of 0 initially, okay, I will just take 1 here, that's it, right? In Deque, what we are pushing, we are just pushing the integers, right? So here I'm going to write integer, and here let's name it as max d, and here new array Deque, and that's it. Okay, this is how. Same way you have to do for min d, so you can just copy this and here paste it, and here just write it like this, min d. So min d is going to maintain the minimum of the current window. All right, it is going to maintain the minimum of the current window, and it is a monotonic increasing Deque. Monotonic increasing Deque. And here in the front we have to store the smallest, right? So like this I am maintaining, right? Later on, if the gap is bigger, right, so I am moving the left forward, right, as I explained. So if I'm moving the left forward, then definitely the difference will be reduced, right? So here it is nothing but min d, and that's it. Okay, so now these are some basics that we need to do. Okay, now our code is going to start very easy, nothing complex. So here int left is equal to 0, and now you have to run one loop. Int r is starting from 0, r is less than n, and here r plus plus, right? And here we have to maintain the max Deque, right? And here you have to simply run one while loop while your max d is empty, right? So if your max d is not empty, initially it is empty, right? But if your max d is not empty, right, this is what I'm saying, if your max d is not empty, and your max d dot peak last element, right? Peak last element I'm checking, right? If the last element is smaller than the new element that I want to insert, right, nums of r, right? So if this is the case, right, if peak element is smaller than this nums of r, in that case you have to remove the element, last element, right? Max dot poll last, right? This is what you need to do, right? So here in the first case, right, let me show you side by side. Okay, so in the very first case, if you see this example, so initially it is empty, right? There is nothing in the max d, there is nothing in the min d initially, right? So what I'm going to do here initially this case will not be executed, right? So what I'm going to do, I'm going to insert, right? So here max d dot add in the last, right? Add last, and here I am adding nums, and here r, right? This is what I need to do, right? Initially I'm adding. Okay, now next time, let's say I added this 9, let's say I added this 9. Now next time if I move further, right, 9 I have, let's say I am at 4. So now what I can add 9 4, I can do it like this next time, or just 4, tell me. So here if you read it, in max d, what we are doing, we are maintaining the maximum of the current window in the very first position, and it is a monotonic decreasing Deque. So first position we are keeping the largest, so definitely we can keep it, right? And here if you see this, max d is not empty initially, right? This right now once I add 9, right? Okay, now I come to 4. Let's say my nums of r is value is 4. Now here max d dot peak last element is 9, so 9 is less than 4. No, right? So I don't need to remove anything, and again I can add 4 freely, right? So let's say I added 4. Now next case, let's say when I reach to 1, so now what will happen, again I can add, right? 9 4 1, I can add, right? Again I can add. So here if you see 9 here, after that 9, after that I can add 4, but here it is showing 4 1. That is some later on we will discuss that case, but we can add. Okay, we can add. Why actually you are seeing just 4 1? Because later on I can't take these three in a whole, right? Because the difference between the maximum and smallest is going to be greater than k. That is not valid, so that's why I have to remove it later on. Okay, but initially we can add, our logic says we can add, right? Because max is nothing but monotonic decreasing, right? Monotonic decreasing, right? So only if the last element is smaller than this, right, only then we have to poll. Okay, otherwise we have to add. Same logic you have to write for min d. Okay, we have to maintain the min Deque, right? So if you just go over this code now and the debug statements that I have provided here, you will clearly understand step by step. Okay, maintain the min Deque, right? So here also you can just simply copy this and paste it here, right? And here you have to just change it to min d, right? Min d is not empty, and here it will be positive, right? So here what you have to do, min d dot peak last is greater than the nums of R, right? In that case, you have to remove the last element. Okay, in that case you have to remove the last element, otherwise you have to add this. You have to always do, right? Min d dot add last, right? Not otherwise, you have to always do this, right? So this is what you need to do. Okay, done. So this is what we need to do, right? So once this is done, once this thing is done, right, this thing is done, then we have to shrink the left. Okay, now sliding window comes into effect, right? So we have to shrink left until window max minus min is less than equal to k, right? So here again you have to run this. Okay, run this. So run one loop, right? While your left is right now it is 0, right? Now once I have both the windows, right, this max d and min d, right, now I can easily calculate the difference, right, between the max and largest element, right? So here what I'm going to do, I can simply do one thing. Now I can copy this, right, while my max d is not empty, right, and I will say my min d is also not empty, right? This is the case, right? And I can say my max d dot, here max d dot peak, not last, first, right? Because first element is going to be maintains the maximum of the current window, and it is a front is good largest, right? So peak first, largest value, right? Max d dot peak first, let's say peak first, right? And and here subtract min d dot peak first here also, right? Because this is going to maintain the smallest, right? Front is the smallest, so min d dot peak first, right? This clear, right? This part, right? If the difference between these two, right, if it becomes greater than k, then whatever the element I have in the left, in the left, right, that I have to remove, right? So if I remove that, then definitely next time my left will be incremented, right? But here first check if in max d and in min d, if we have that element at nums of left, right, only then we can remove, right? So here if what I'm going to do, here I'm going to do, if max d dot peak first, if the first element here, if it is equal to nums of left, right, only then we can remove, right? Only then we can remove. So here I can do max d dot pole first, not last, first element we have to remove, right? So max d dot pole first, this is done, right? Same way, now this is for max, same way you have to check for min d as well, right? So here if min d dot peak first is equal to nums dot left, nums of left, then you have to remove min d dot pole first, and then you have to do left plus plus, that's it. This is very easy, right? This is very easy, right? So this is what we are doing here, right? This is how we are going to maintain the window, right? This window, if you see, always here I am maintaining, right, so that I don't get some window like this. Okay, so here 4 I'm removing, now left is equal to 2, then at 2 maybe I will find 1, then I'm going to remove 1 from here, then I left with 7 and 3 7, then again I will check the difference. Okay, so this is what I need to do. Now only few lines of pending. Okay, so this thing you already know, right? dp of r plus 1, this is nothing but, if I say something like this is something what you can say, sum from dp of, let's say, left to r. Okay, left can be anything until r. So you can ignore this part if you want. R plus means until r, right? This is what we say here. dp of I is nothing but number of valid ways to partition nums to 0 to I minus 1. Okay, now here this thing we need to do, right? When we were doing this part, right? So here when I want to do here, so I need to take the total until here, then from this I need to subtract this so that I get this, something like this, that, right? For this, let me use some other pen. For this, we have to get this, subtract this, so that I get this and I get this value. Okay, something like this we have to do, right? So here, so first I will take the total. Long total is nothing but I can say P of R, right? And what I need to remove from this, what I need to remove. So here I will check now if my left value is equal to 0, right? Left, if left itself is equal to 0, then just take the 0, then we have nothing to remove. Okay, I don't want to go out of a bound, right? Otherwise, whatever otherwise if I have some value of left, right, so I have to do pre of left minus 1, because this value I will get at minus 1, right? Left minus 1, right? This is what we need to do. So for left minus 1 we have value, right? dp of left, we have left minus 1, right? So just like dp of r plus 1 means until r, right? So that's the logic that I'm trying to use. Okay, so now how you are going to get the value of dp of r plus 1. So dp of r plus 1 is nothing but very simple, right? So what you have this total, right? From total you have to subtract this remove part, and just value can be very large, so just do plus mode, and here modulus with the mode, right? Modulus with the mode. Why I'm doing plus mode here? Because this value may go negative, right? This value may go negative, right? So just to be on safer side, I am doing this plus mode, this, okay, like this. I will get correct value only. Okay, and here I told you that how I'm going to update my prefix. So how I'm updating my prefix? So this value I'm updating with this is nothing but, let's say, pre of r plus 1. So this value I'm operating with the pre of r plus the dp of r plus 1, right? Then I'm operating this. So this is the logic that I have to use, right? So here you have to write pre of r plus 1 is equal to pre of r plus dp of r plus 1, right? And here just do the modulus with mode, that's it, right? And in the end, here in the end you will have final answer, right? You will have final answer, okay, in the dp of this, right? So this 6 is nothing but the combination of this 2 4, right? This 4 is not nothing but the combination of 1 1 2, right? Okay, so this we already discussed in the starting itself, right? So dp of n, so return dp of n, so that simply means from 0 to n minus 1, 0 to n minus 1 I have stored the answer here in dp of n, right? Because dp of I is nothing but 0 to I minus 1, right? Nums of 0 to I minus 1, right? So now let's do one thing. Let's run the code and see if there are code issues. We'll try to fix that if there is anything issue, right? Nice. So all the test cases have been accepted, right? Wonderful. Now let's submit it. So see, our solution is accepted, right? So I hope that you guys are able to understand today's problem. And if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.